Okay, we're going to continue. Go on, Isaac. Let's start by asking if everybody is up to this point. Go on.
Okay. Any student, can you do it this geometry to this part to this part? Any student, can you show me, for example? Let me stop. For example, Álvaro Ortega. Álvaro. Ortega.
Yeah, today, but I'm catching up just
Okay.
2 minutes. Yeah, no problem. I will let you know.
Okay. Other student, Karen Kumbe. Karen Kumbe.
Yes, yes.
Can you show me your screen in order to see the geometric in the rhinoceros?
I have that problem. Is I have the other last version. I now use
In rhinoceros. Okay. Okay. Any student, can you show me to this point? Any student?
Andrew, yeah,
okay, Jimen. Okay, Jimen, go.
I didn't. So right.
Wow.
You complete all.
Did you copy from somebody?
No. It's easy that.
Okay. Okay.
That's nice. Good. Good.
Nice.
I like it. So you're a good instructor. You're a good instructor, Isaac. You can take my place now.
Okay, we are going to continue now.
Exactly.
So the next step is the same. So you have to extrude this profile along to this line, right? So click in this profile of the thickness, and then go to the surface, select extrude curve, and then along the curve. So then you have to select a path. So this is the extrude of the profile of this. Okay. So the next step is to copy. So copy this profile, this surface, to every point. One moment. One moment. Okay, so copy to this for each point. At each point, copy for each point. Each point. The last one. Yeah. So there are 2, 3, 4, 5, 6, 7, 8, 9 thickness. Okay, so then you have to select these those stiffener, and use the tool mirror. So type mirror and then enter, and select this point in the middle of the plate, and you see that the other part can draw for the symmetry. Okay, so next you you can hide the ISO curve, remove these points, and the final step, you have to delete every line that you draw, because you have to import only surface. So for this part, go to these options. So um, select all lines, all curves, and click on the delete in the computer, similar to the points, because there are points in this part. So you have to go to this icon and select points. So you see that the points are selected, and then click on delete on your computer. So this is only surface. So the final step is select every surface and move to the 0 point. So click on move, select the point that you want to move, and then click the point 0.0.0, and then enter. So you see that the geometry is located in the 0 point, in the original point. Okay, so that's all of the geometry. Okay, questions, student, questions so far? Questions? Can you do it? It's easy, difficult?
Excuse me, can you repeat the lead lines and points?
Okay, go to these options. Go to these options. And you see that in this icon, in the right part, there is an arrow. So click to this arrow, and you see every options that you can select. You can select by lawyer, by faces, by line, by points, by solids. So you, in this case, you can select curve, and you see in your screen that the curve are selected. The same for the joints. The same for the points. Ruiz?
Okay, thank you.
Okay. So finally, you have to save this geometry in EHS format. Okay. So file, save as, and for example, bottom plate, and the type of this file, you can select that you, if you want to save in the previous versions, 6543, but you in this part you have to select EGES format, EGES. Okay, so select EGES format and then save. So you see now, okay, so then the next step is to open. I think that as practice 1. This is the file that we did in the previous class, right? Practice 1. So
Engineer, I have a question. I'm sorry.
yeah,
When I save on EJS, in EJS,
EGES format.
in ES form, yes, there is a notification for me that how I can save it in ES unit. The program asked me right now. Can
Okay.
I have to say on inches too?
Yeah,
Okay.
in inch. Okay. So remember that this is the two exercises that we did in the previous class. So similar, drag a static structure to the weight space, and then remember that engineering data is for to put the mechanical property of the material, okay, and the geometry. Right click in geometry, and then enter to the new design model. Okay, so go to the file, and then you have to use this part that import external geometry file. So select import external geometry file, and you see that this is bottom plate in this form. So select bottom plate, and then this is the input ones. You can and then you have to click on generate. See, you see the geometric. Okay, so remember that the geometric is in the unit is in inch. Okay, so you have to change the unit in inch right now. Okay, so the final step is to assign the thickness for each element, right? So you see in this part there are two parts, two surface, 12 surface. So you see, for example, the shell, the other shell that you see in the yellow in the yellow part. So you see the thing, right? So the other stiffener, the other stiffener, the other stiffener, the other stiffener. This is the, you see the flange of the longitudinal girder. The other is the web, and the other is you can enter the thickness. For example, the thickness of each stiffener is 3/8. No, is 5/16. So in inches, 5/16 is thickness of the stiffener is 0.3125. So this is the value that you have to input. So you can select, for example, if you want to assign the thickness for all the thickness, you have to click on the first thickness and then select shift and then go to the last stiffener and select this part. So the all the thickness are selected now. So you can input the thickness now. So in the thickness mode, change to the user defined and then the value of the thickness. So it's 0.3125. So right now. So you see in the upper part, in the lower part, the thickness for each stiffener. So in order to organize this geometry, you can rename this part. For example, you can rename and call, I don't know, a stiffener 1, and the second stiffener 2, and go on. So the same for the flange and web. So you can rename and put, for example, flange. So there, and then rename. You put the names web, and the other surface rename and put bottom plate. Okay, so the thickness of the flange is 0.5, and the web is 0.375. Okay, flange is, you have to change to the user defined and then input the thickness 0.5. Web, so for the same, and this is 0.375, the same for the bottom plate. 0.375. 0, that is comma 375. Okay, so that's all. So this is the geometry with the thickness of the structure. Okay, remember, always save project, always, and then you can close the window. So now is finished the exercise. Questions so far? Questions. Any student can, let me stop the screen. Any student, can you do it, this exercise? Can you import the geometry to the Rhino, from Rhino to the ANSYS? Any student?
Yes, engineer.
Can you show me? Can you show us?
Yes. Yes.
Okay.
Did you assign the thicknesses for every part of the structure, Ms. Vera? Ms. Vera, did you assign the thicknesses for each part of the structure? Ms. Vera, can you hear me?
Right.
Okay, it was nice because she changed the names of the elements, so she can easily identify each one of the elements in the structure. That's a good practice. That's a good practice. Okay, let's move on, Isaac,
Okay.
to the next exercise.
Okay. Let me. So the next exercise is to create a magic block of a passenger ship. So you have to draw the sign plus bottom. So this is a part of a ship, but the ship is a passenger ship. So you can see the frame in this part. For example, you see the thickness of the plate, that this is 8 millimeters. This is a longitudinal girders, that this is plate also, and the thickness is the same. So the bottom, the inner bottom is 6 millimeters. In the side, you see a frame. So the frames is, you can see in this part of the frames the profile of T. This is frames that is a 80 millimeter per 60 millimeter, and the thickness is 8 millimeters. So you see that in this part you see the wet frame, that this is a big frame. Okay, this is more higher in this part. Okay. What else? What else? So this block is between ball head, from ball head 30 to the ball head 37. So this length is 3 meters, 0.778. Okay. That's all. So in this part, we're going to modeling the rhinoceros. So we start with these stations, with this frame, with the stringer and the double button and the side gear, and then you have to extrude this line in the x-axis, that the extrusion is these dimensions are around 3 meters, and then you have to in the next step, then you have to correct, or you have to improve the surface in the side buttons. So you see when I explain in the rhinoceros front. So next you have to use the tool contours in order to draw lines in the side plus bottom. And then you have to split this line as I shown in this figure, part 1, part 2, part 3. And in this, in those parts, you have to extrude the profile of the frames, and the wet frames, as I shown in the step number 6. So you see that this is a profile, and then you have to extrude along this line. So it's easy to follow this step. The same for the part 2 and the part 3. See, you see the other elements. Finally, you have to create a solid floor and then the bracket floor. So always remember that when you create a surface, you have to use surface from neighbor or curve. Remember this tool, right? So that's all. You have to delete every lines and points, and then you have to input the geometric and assign the thickness in the ANSYS program. So now we're going to do in the ANSYS program. So maybe, Doctor, this is a second break, right?
Yeah, this is a good point to make a break. People, all of these instructions were handed to you. So you can take a quick look at these instructions, because when we return, Isaac is going to lead you in the development of this exercise. So it's basically very similar to the other, but there are a couple of commands, extra commands that you have to employ. But please take a quick look at the information that Isaac sent to you, so you can follow the instructions easier. Okay, so let's take a 5-minute break here. Okay, 5-minute break.